Hello and welcome to Database Management Systems. I'm Jovita Christie, and in this video, I'm going to explain to you, continue explaining to you the ER model with specialization, generalization, and aggregation. And I'm also going to explain to you an object-oriented model. So let's begin. What is a specialization? So here there's a diagram that I've given, and this is the diagram of specialization, and I'm going to tell you what it is. So specialization is a refinement from an initial entity set into successive levels of entity subgroupings in a top-down manner. So for example, if you're designing a database for a university and initially you only recognized a person entity set. But then after creating the person entity set, you realized that every person does not have a salary or total number of credits because every person, for example, may be a different entity. Like if a person is an employee, then he or she could have a salary, but not total credits. And if the person were a student, he or she would have total credits, but not salary. So you decided to then classify person into student and employee. So this classification would be called specialization. And then you can further classify an employee into an instructor and a secretary because they too have attributes that are different. For example, an instructor is having a rank attribute that's not available with a secretary, and secretary is having total number of hours per week, which is not the case for an instructor. So this concept of a top-down approach where from the top you start refining and creating more entities, classifying, that is known as specialization. An entity set may include subgroupings of entities that are distinct in some way from other entities in the set. This distinction is because of the attributes. Like I said, employee is having salary, but student does not have salary. And same with total credits. Student has total credits, but employee does not have it. Now, just like you have generalization, the opposite of that is, just like you have specialization, the opposite of that is generalization, which is an approach where you begin from the bottom instead of the top. So designing in a bottom-up manner in which multiple entity sets are synthesized into a higher level entity set on the basis of common features. So that would be generalization. So you would start right from the bottom and then move upwards. So for example, while creating your database, if you first identified that you have two entities, employee and student, and so you created only two entities, employee and student, and added all these attributes. For employee, you added ID, name, address, and salary. And for student, you added ID, name, address, and total credits. But then when you look at those, you'll realize that student and employee, they have a lot of common attributes. So why not collect all the common attributes, because if there are lots of common attributes and you create a diagram, then diagram would be really big because you're repeating so many attributes. But instead, because there are common attributes, you could merge them into an entity set and put it on a level above employee and student and put those attributes on that higher entity set. That would be generalization. So it's just the way you think. If you are thinking from the top to bottom, it is specialization. But if you're thinking from bottom to top, then that is a generalization approach. Now, the commonalities can be expressed by generalization. And for all practical purposes, generalization is a simple inversion of specialization. You don't have to do anything special. In the diagram itself, the diagram remains as it is. There's no change whether you're showing specialization or generalization. Generalization is used to emphasize similarities among lower level entity sets and also to hide the differences. So this is what generalization is. It also permits an economy of representation in that shared attributes are not repeated. So like I said before, if you perform generalization, then all the attributes which are shared, you don't have to go on drawing them over and over again because you just draw them once for a higher level entity set. So it gives you an economy of representation. Now there are types of generalization and specialization. We are going to see those now. The first type is an overlapping one, where an entity may belong to multiple specialized entity sets. For example, in a university, you might be having somebody who is a student as well as an employee. Maybe that student is working on campus for for the post of a librarian, or maybe the cleaning staff or somewhere in the canteen. So all these things can be combined. And so one student could also be an employee. And let's just take an example. If you have a student ABC who is a student as well as an employee, then the data of ABC will be present not just in the student table, but also in the employee table. So such a generalization or specialization, where although you have separated two entities, there are some overlappings between them. That is known as an overlapping generalization or specialization. And to show that it is overlapping in the diagram, we do it by showing two arrows. So you can see here there are two arrows. Two arrows. Both the arrows are having hollow hollow arrows. Generally, it is expressed using hollow arrows. We never color those arrows. They are called hollow arrows. And they are two separate arrows. The next type of generalization or specialization is called a disjoint one, where one entity may belong to at most one specialized entity set. For example, a person who's an employee cannot be an instructor and secretary both at the same time. And so you would be putting an employee only in the instructor part or in the secretary part, not in both. And this type of a specialization would be disjoint to show that we would be putting one single hollow arrow instead of two separate ones like we did in overlapping ones. So this is one single hollow arrow, and from that one arrow, we will create the specializations. This is the last concept in an ER model. It is aggregation. And aggregation, you can say that it is a form of a quaternary relationship shown in a better way. So aggregation is an abstraction through which relationships are treated as higher level entities, and it is used to express relationships among relationships. So if you have one relationship and you want to express relationship of that relationship set with another one, then that is what aggregation will help you to do. Now in this diagram, there is a ternary relationship between instructor, student, and project, which is called project guide. But along with this, I also want to provide information about what is the evaluation. What marks did the instructor give to that student for that particular project? And not just marks, but maybe some comments, how to improve, and some grades and things of that sort. If I want to give that, maybe a monthly evaluation or weekly evaluation, then for that, I would have to create another entity set. And once I create another entity set, I can store it like that. But the problem here is if I have created another entity set, then it would become a quaternary relationship. And quaternary relationships are fine, but they don't really make a lot of sense when you try to put them in the diagram. And so the best way to do this is to combine the three three entities that you have, draw a box over them, and then attach a fourth entity set with it by another relationship. So you can say that this eval for relationship that you see here is actually attached with project guide, not with an entity set. That is why you can say aggregation allows you to create relationships among relationships. We regard the relationship set, which is project underscore guide, relating the entity sets instructor, student, and project, as a higher level entity set called project guide. So project underscore guide is a higher level entity set in this, although it is a relationship. We regard it as higher level entity because otherwise I would have to just add a lot of descriptive attributes with project guide, grade and the date on which evaluation was done for each and every instructor student project triplet. I would have to add so many descriptive attributes, and that doesn't make sense. Maybe one or two descriptive attributes make sense, but adding several does not make sense. So instead, you could just create another entity and then create another relationship and attach it with that. So here, the relationship set project underscore guide is treated just for the aggregation purpose as another entity set instead of a relationship set. And then the relationship that is actually created between project underscore guide and eval4 is a binary relationship, not a quaternary one, because as such, you are only connecting two entity sets, because in aggregation, project underscore guide is considered as an entity set. So you're just connecting one entity set with another one. So it's a binary relationship, eval4. Now we are going to proceed. And yeah, I would also like to mention that that's all you need to know about ER diagrams. With those symbols, you can make any ER diagram that you want. And now we're going to see one last data model in DBMS, which is object-oriented data model. It looks something like this. This is mainly used in programming languages which are object-oriented, like C++ and Java and Python and other languages. So it just defines, which are the different classes available, and then for those classes, what are the different objects inside, and then for those objects, what are the different methods. So that's an object-oriented model. Here, if you try to compare it with an ER model, then in ER model, we have entities. Those entities in object-oriented models are called objects. And objects have properties and methods. And a class is a collection of similar types of objects. So when some objects together are similar, then we create a class out of those. Now let's see the analogy between an object-oriented model and a relational model. So in this, a class is used instead of relations. So whatever you were describing as tables, here you will be describing that as a class. An object is used instead of tuple. Tuples are rows. So instead of rows, we would be having objects. And properties are used instead of attributes. So instead of the columns in the table, we call them properties. Methods are used instead of stored procedures. Now, you might not know at this point what a stored procedure is because it's not yet available. Stored procedures is something you will learn in PLSQL, which is a procedural language SQL, a programming language that you can use with a database. So in that, you'll study what a procedure is. It's basically a function that allows you to repeat your code without having to write it again. And so that's what a procedure, stored procedure is. And in an object-oriented model, we just create a class. Like you can see here, there's a class called customer, and with customer, there are several objects. You will be creating several objects of customer. For example, if you have a customer and you want to store his or her data, then that would be an object. And customer is having properties which are present right in the box after customer. And also there are some methods associated with customer, like you want to get the full name of customer, get the address, all those things. And then you can see there's 0, 1 done for the connection between customer and another class, which is actually showing to you the relationship between customer and address. So that is how you can show a relationship, just like an ER model. You can draw a line and show relationship. So that's how the object-oriented model looks. And that's it for this video. I'll see you in the next one. Thank you for watching.